All right, lesson 3. Mobile box controller. So we're going to enable mobile control via a custom input manager. Or, yeah, it's an input manager. It manages keyboard and also mobile input. So here for our mobile box controller, we've inherited from our previous box controller script the ground and jumps have been abstracted away into a separate class that they can both use. Our spawn point limit Y is still the same. There's no changes there. Our push controller also remains the same. And we still have our pickup. Our pushable cube, it's not been changed unless I change the shade, the material. Not sure. I use legacy shaders on my machine. The standard shaders, they don't show on the build on my machine. It's invisible. So I'm forced to use the legacy shaders on my machine. You may not be, however. Okay, and what did we do? There's a prefab. Okay, we added these 2 prefabs in lesson 2. I didn't show you that, but we drug the goal over in the player model, which is just the regular box. Alright, so onto the mobile box controller. Actually, let's start with the input manager. Okay, good. It's already up. So here's our move direction and our jump input. Now, these are both properties that just returns the current input. So in my case, I'm using Android. If you're on another mobile device, you can select it here. And for me, everything else, I'm just going to use the regular keyboard input, which I'm assuming is going to be a standalone build. You make the decision on what needs to be done in your case. So if I'm running on the Android device, we're going to access the accelerometer and get the X movement out of that. So we check to see if it's greater than 1. Square magnitude is a little faster math, and the squared magnitude and the magnitude, I think you can check for greater than 1, and then you can normalize to make sure that the vector length never exceeds 1. That way we can multiply it by our speed and get a consistent output each time, as with our input manager. This never exceeds the value of 1. So we need to mimic that behavior. And that's what this line of code does. And that's for our move direction. We're using that in our mobile box controller. Now onto the jump. It's the default jump that we've used before. And if we're on an Android, again in my case, I check for the touch counts. And there's another touch count, I believe. I'm not sure if it's a property or a method. It's recommended to use this one. I think the other one may be deprecated. Let me get back to where I was. Okay. So we have our touch count. If there is a touch, then we get the touch phase began or stationary. So when the user first finger touches, we say that's good. And if they keep their finger down, we say that's good. Because remember, we want to mimic this ability. And this gets the jump once the button is held down. So we want to continue to have that same behavior. So we don't want to just began. We want began and stationary once it's there. Alright, so that's our input. Let's go to the mobile controller first. So this is our mobile controller. It inherits from our movable box controller, which was in lesson 2. Let's get back there and take a quick look at it. Abstract class that has a few functionality already embedded. So now here's our jumps. So we have our jump info, which we just went over. Well, we haven't been over that. We will go over it. I want to introduce you to its usage first. So our ground and jump info, we set the default constructor values, have accesses for them for outside access. We create 2 new methods that are virtual and can be overridden in derived classes. So get move input and get jump input, and those will get the input from the input managers. Then we have 2 more virtual functions that coincide with the speeds of each of the jump. And so these are the actions that are going to happen. So we've seen this code before, setting the Y of the move direction to the jump speed, and that's on when you do a jump. So this will do the same for the wall jump. It says the Y direction of the wall jump speed and then inverses the move direction on the X plane. So again, we've abstracted out this behavior, so and it's virtual, so it can be used in derived classes. We override the ground movement and wall jump movement, and this is where things change to receive. The ground jump and the wall jump have methods to get input. Give it a delta time, keep things consistent frame rate wise, and it needs whether it's jumping or not, and this will tell whether it's jumping. And this is a function that we went over here, get jump. I could have just put this in here, but I realized later down as the project was growing that I needed to abstract the function out so it can be changed later down. So that's why it's not just hard coded right into the jump input. And then we give it an action to perform once it detects that there was a jump input, and we do that also for the ground. We still need to know whether we're moving or not, but we're not using the controllers as grounded function anymore. We've created our own that will check for wall and ground jumps. And this is a class that is it class or a structure? It's a structure that can be used for, let's say you want to do different things when you hit from above. Then you can just add a head jump function, I don't know, above jump, and continue along the same path. Tell it when the jump happened and what do you want to do when the jump happens. And we override our on hit collision and pass in our base class to draw our debug rays and set our hit property. So now into the big change here, let's see what our jump if roll structure looks like. I've chosen to use a structure in this case because everything in here is simple types. their structures themselves. There's no class variables contained within this structure, so I decided to make it a structure instead of a class. So it declares the max speed, max jump speed, the range of which we can set the sensitivity, and we have some local variables here. The speed that it's currently jumping at, whether it's grounded or not, and the collision flags we're going to be checking for. We have public accessors for each, and they're only accessors. You can only get the values. So when we instantiate one of these structures, we set up all the values and we initialize the internal fields. When we call getJump, this function also we've seen before. It's abstracted from the grounded controller. Let me see if I can find that. So here it is. And now here it is. So now the jump info is responsible for doing everything jump related. It knows when it's grounded and it can jump. It gets the input and it performs the jump action with the analog jumping, and it defines and sets its own is grounded function depending on the collision flag that was passed in, and we've seen this bit comparison before. I believe that's what it's called. If it's not, I do apologize. So that's our jump info structure that handles all our jumping. So our mobile box controller, the fact that we're inheriting from base classes that's been previously built, functional, and works, simplifies our work as we go on. As we need changes, instead of adding them into, let's say we want to make a swimming controller or something, instead of adding all the functionality directly into this mobile box controller, we can just inherit from the class and add in the specifics that we need just for that. And we have everything else. We have whether it can jump. I guess then we'll put is water grounded or something to detect for if you can jump out of the water, things like that. It's very easy to move on to that step now without really having to change a whole lot. So we're in lesson 3, been over the input manager, which gets the jump input from the touches as well as the keyboard, the movement input from the device accelerometer as well as the keyboard. Went over the jump information encapsulation, where we abstract away all the relevant jump data and let one object be responsible for handling that information. And we've implemented our jump box controller, or mobile box controller. So here we have it running. It works. I thought about plugging in the Unity remote and having a sample shown on the screen, but you really still can't tell whether I'm pressing the keyboard or tilting the device. So write it up, build it, and you'll see it works. Anyway, on to my usual, trying to get all my goals. Hang on here, let me click on lesson 4, and that way I can say what's going to happen in the next tutorial while I mess around here. There's the broadcast pickup, and I think that's an interface that we're going to implement, or an event. That's what it is. It's an event that's going to be fired whenever a pickup has been collided with from the player, which is pretty cool because we never have to change our original pickup script. We have checkpoints that we're going to be implementing and a rudimentary game controller. It's going to count our pickups, and that way we can change the level when we pick everything up. We'll see how tags are used. We'll implement those in a utility that we can access from anywhere statically. And we'll see how the system events and system event args are passed around. Unity, not Unity specific, these are C# specific that can be used in Unity. So I hope to see you then for lesson 4, checkpoints and rudimentary game controller. Thank you.